Good morning, everyone. Today we are going to be talking about code style, and thank you very much to the patron of our class, Miss Taylor Swift, for bringing us in. So the notion of code style is important because just as much as the computer is going to read your code, you are also going to read your code. Not the you right now writing it, but future you. And so it is going to be critical to write code that is actually readable and maintainable both by you and by others who may read your code later. So we're going to go through a number of different examples of both good style and bad style and talk a bit what makes code Pythonic, what makes it fit into the kind of readability that programmers would expect to see from Python code. Every language is going to have its own conventions, its own different styles, and because we're using Python in this class, we're going to try and write code that's as Pythonic as possible, code that people who are used to writing Python will recognize, and this will help them understand what your code is trying to do, as well as maybe in some instances actually make your code more efficient as you use the ways to write Python code that Python is naturally adapted best to doing. So here is our first code example of the day, and we're going to go through a whole bunch of these. That's going to be a lot of our day today, is just going through these interesting examples and trying to figure out what might be wrong with them. So to kick us off, we're going to start going through audience members one by one through all of you, and you're going to help me figure out what is wrong with the code. Okay, so let's start off here. What was your name? You're going to have to speak into the microphone a lot better than that. Bella, awesome. Okay, what don't I like about this code? What makes me unhappy? Yeah, so that looks kind of funny. Do you see where are the places where we might want to put some spaces in? Yeah?
And then for the line, it will calculate and then a space before the plus sign and a space after plus sign.
So something a little like that? That's what you're intending?
Yeah.
Okay, Bella, thank you very much. And can you tell me why we might care about that? Like, why was it bugging you?
Like it reads, it's nicer this way.
It's nicer, right?
Yeah.
And it makes it clearer to the reader actually what's going on, because if you see too many symbols smushed together, if particularly in this is just a small example, but if you see this in a large block of code, it'll actually get more difficult to figure out what the code does because your brain will have a harder time parsing it, have a harder time reading it. So that's our first example. And let's talk for a second about something called PEP8. Now, Python is known for having a lot of different proposals that people in the community who use the programming language suggest for changes to Python. And these are known as Python enhancement proposals, or PEPs. And they're all given a number. So PEP8, one of the earlier PEPs, is the style recommendations, the style enhancements that people recommended that people programming in Python should follow. So we can actually look this up online. We can look up the Python enhancement proposal, and this is what it looks like. And this was created on the 5th of July 2001, and every now and then gets updated with what people think good style, well-styled Python code should look like. And so your assignment for the next 8 weeks is to read all of PEP8. Why are you looking at me funny, Bella?
Nothing.
No, go ahead.
Oh, well, it's kind of long.
It's kind of long, right. So we're not actually going to require you to read all of PEP8 in detail, although checking from time to time, looking through some of these Python proposals for new features that you want to use can actually be a good way of understanding why things are done a certain way. So for example, in PEP8, it talks exactly about like why you should use tabs or spaces. Why might we prefer one to the other? Why might we prefer certain styles of capitalization? And actually details not just a good practice, but why one might follow the practice. So I would encourage you, even not reading the whole thing, to just bring this up and take a bit of a skim through it. And these are the rules that we're actually going to start requiring you to follow in your own code. Now, there are a lot of rules, and don't worry about having memorized all of them. We'll talk about a way to make that a bit easier for you pretty soon. So here is another example of some code that makes me unhappy. Bella, why am I unhappy? If you want, you can pass, and by pass, you pass the microphone one back. Okay, what was your name?
Clarice.
Clarice?
Yeah.
Awesome. So Clarice, why am I unhappy? What's wrong with my code?
Maybe because like you write too many and in and they're kind of.
Speak a little louder.
Maybe because you write too many and in and they kind of link together, so it's kind of confusing.
Well, maybe I have too many ands. There's something about that. Let's see, where if I start reading the code, if, blah, blah, and I get all the way over here, right? There's something a bit unpleasant to read because this line of code is really long. And so another thing that we're going to recommend is that you keep your lines relatively short. In fact, a typical recommendation that programmers use is to keep your code under 80 characters in length per line. And there are ways of breaking up lines, and we'll see how to do this in a moment. But this is actually because old school computers, very, very early computers, actually used these things called punch cards to write their code. And so instead of typing letters, you would individually poke out holes on this piece of card, and there were 80 holes in a row, and the computer would read those 80 holes to figure out what the instructions were. Now, thankfully, I'm not going to make any of you program via punch card, and this was tedious and time-consuming. And you would also have to you'd have to insert into the computer piles and piles of cards, like 100 cards at a time, in order to actually do your full program. And then if you dropped your cards and hadn't labeled them in the order, you were pretty much screwed. So because there were 80 lines on the punch cards, when we started to create physical computers with monitors, we also created terminals, like monitors, that would support 80 characters on a line. So this is going back a bit into computing history. So if we improve our code from before, now we've kept it to within our 80 character limit, and it suddenly looks a lot better. That's a lot more readable, and I don't have to walk all the way over here just to read the end of the line of code. Thank you, Clarice. Okay, next one. Clarice, do you want to pass it behind you maybe to Driti?
I think with this one, the space between the brackets and the characters, that should not be there.
So I still have some inconsistent spacing going on, so let's clean that up. Okay, let's take a look at that one more time. I had a space after the word len, but before the parentheses. That code would still run, but it looked a bit ugly. I had an extra space over there after on line 3, after the colon, so we got rid of that one. And generally, I just condensed my code, but not so much as to make it unreadable. And again, once you start to program a little more, you'll get used to which of these kinds of spaces are necessary for readability and which of these are excess. Okay, next one. This is a little bit trickier. You can pass to the side if you want as well. What was your name?
Gayatri. Gayatri.
Gaichi?
Yeah.
Awesome, okay. So this one's a little tricky. Why might I want to make a change to this code?
Maybe you could add like a space before the for loop, or
Bit louder?
maybe you could like add a line before the for loop.
Okay, and why might I
Make
do
it more
this?
Neat, maybe.
Why would I add a space before the for loop?
Make it more neat or like simple to read. I don't know.
Make it more readable. Divide the code up into logical blocks where the spaces and the paragraph spacing indicate different chunks of my code that belong to different ideas. So just like we might use functions to divide the code logically up into different ideas, we might even do that within functions once they start getting a bit longer. So here I've separated out the for loop so we can easily see that this for loop represents a discrete idea in the code. We have the setup of our variables at the top and then the return down at the bottom, all nicely separated. Okay, next one. Pass it one back.
Instead of semicolons, you could have the next statement in the next line.
That's a nice idea. What was your name?
Imad.
Imad.
Yeah.
A Turkish name?
No, Saudi Arabia.
Saudi Arabia. Awesome. Okay, so explain what you wanted us to do with this one.
It's B equals 0 could be on the next line instead of the same line.
And anything else?
And the loops as well. B plus equals 1 could be on the next line. B plus equals 2 could be on the next line as well.
So while someone has been very, very clever with this code and used the semicolon to say, look, I can do 2 Python things on one line, and then I don't even need to create a new line after my if statement and after my else statement, this again impedes readability. So if we were to do something more like this, then all of a sudden our code it's much clearer to the reader what the code is actually doing. So let's take a look at that one more time. Now we have A is true up on its own line, B equals 0 up on its own line, and everything is nicely spaced. Okay, Imad, pass it one back again. And what is your name?
Betty.
Becky?
Yeah.
Awesome, okay. Why am I sad?
Because they are 2 equal in one line.
Speak a little louder.
Because there are 2 equal in one line.
2 equals in one line. Okay, that could be a reason. That's reason one why we might not be super happy. What else is tricky about this code? Do you know what it's doing?
Because there is O equal to 0 and they look so similar.
Yeah, they look really similar, O and 0, and L and I and 1, right? What would you do if you were the one writing this code?
Maybe just change, maybe just use other, like A to replace O.
So let's say we can choose any word in the whole world to describe our variable names. What is the best practice, do you think, for naming our variables? Is it calling it just a single letter?
Maybe add some meaning.
Yeah, add some meaning to it. So I haven't actually told you what this code does, and that's partially because I've used variable names that obscure the actual function and purpose of the code. So something like this might be a lot more intelligent. So now I can actually have the 2 equals on the same line because now it is clear what my code is doing. So while there'll be instances in which you do separate it out, not every time you'll necessarily want to follow every rule about condensing things. So it's a balance between making your code neat and making it readable, and also ensuring that you don't make it overly verbose. So you could declare every new variable on a new line, but sometimes variables are actually going to be grouped together, performing a similar function, and so you may actually group them together in this case. Oh, so you already have. What was your name?
My name's Ethan.
Ethan. Okay. What's wrong with the code?
Again, just issues with variable names.
Okay, so what would you do in this one? Can you figure out what this does?
Not easily, no.
Okay, if you had to guess.
I'm guessing it would be like adding up amount of coffees that you're buying or something like that. And
Well, we do have something here that's a little helpful for us, and we see we've got this hash. Have you guys seen this pound symbol before in class? Right, remember, what is that? Ethan, do you remember what the pound symbol does?
multiplies. Oh, pound comment.
The pound symbol.
Yeah, comment.
It's a comment. So this helps us to document our code, and while this is a reasonable way of doing things, using comments doesn't actually replace the need for clever variables. When people talk about self-documenting code, that doesn't mean that you don't need any comments whatsoever. Rather, that means that you've labeled things well enough that the comments aren't necessary in every place where they would have been had you used variable names that were inscrutable or opaque and hard to decipher. So in this case, we have exactly the same code as before, but suddenly it's a lot clearer what's going on. So what we're figuring out is Ethan,
How much that you're going to be paying for something and how much money you'll be saving.
yeah, so given a certain discount, so let's say the car is on sale for 10% off, what is the final price of the car after having applied the discount? Okay, so now we come to a bunch of rules that are just more conventions rather than anything else. So there's nothing that actually makes me sad about the code at the top. But the code at the bottom is going to be the convention in Python. In Python, typically when we have functions that contain 2 words or variables that are like a mix of 2 words, so for example, calculate average cost, instead of having a convention like that, where we have all the words mushed together and perhaps capitalizing some of them, in Python, it's going to be convention just to add an underscore between the words and keep it all lowercase. Now again, you're not doing something wrong if you don't do this. It's a convention, and it helps you identify whether code is matching kind of common conventions for Python and not. And it helps it appear readable because people know, again, what to expect. Another convention, and this is one that carries over across all different, not every programming language, but a large variety of them, is that we're going to put values that never change in all caps. These are also known as constants. So for example, pi, the value of pi doesn't change, and so if we're making a variable to contain the value of pi, we might label it in all caps to indicate to the person reading it that that value shouldn't change. Now, in some languages, you can actually enforce this much more strongly. So if you write certain lines of code, you can make sure that the variable doesn't change. Python doesn't provide as easy a way to actually do that strictly. So the way we can indicate to other people who are using our code and perhaps building on our code that a variable shouldn't change is by making it a constant in all caps, and that way they know. Again, this doesn't mean that someone can't come in and change that variable. It's just an indicator to them. And you can see there we're using it in our function, in all caps there again. Another example of something that is not Pythonic is to explicitly check if values are equal to true or equal to false. Now, where's the microphone gone? Behind Ethan, right? What was your name?
Zhe.
A little hard to hear, but that's okay. I'll get your name from you later. Why might we prefer the bottom set of code? What's nice about the bottom code, and what's nice about Python that makes this possible?
It's more corresponding to the Python syntax.
So Python actually allows us to very easily check if something is true or false without explicitly saying so. If we do if followed by the variable, it will automatically return true, or it will automatically follow the true branch of the if statement if that variable does indeed evaluate to true. So what are some examples of things that evaluate to true in Python? Someone say something? 1, right? The number 1, for example, evaluates to true. Anything that actually has contents and that seems to exist in a sense is evaluated to true. So let's try this in the terminal on my other computer. And let me just pull that up and make the code window big enough. So I'm going to run the Python command, and this will take me into the interactive terminal. In this case, I'm using a version of Python called IPython, which just makes things nicer and easier to see. So now I'm going to try some things out. So if I put in the number 1, okay, it doesn't do anything exciting, but now I can do something like 1 equals true, and it'll tell me what Python thinks of this. So 1 equals true is itself true. So you can imagine I've just put parentheses around that and asked Python to evaluate it. Likewise, I can do something like test if an empty tuple, let's do an empty tuple, is also true. And that's false because it's empty, so there's nothing in it, so there's a sense in which some things are truthy and which some things are falsy. And so when we go and write our code and think about Python style, because of this Python language feature, it's actually going to be much more indicative of good style to exclude the equals false and equals true, because this is a Python feature that's built there to make our life easier and to make it so we don't explicitly have to write this kind of code. Now we get to an issue of some contention, and that's how should we use comments? And do you want to pass the microphone either behind you or to someone who hasn't had it yet? Hey, what's your name?
I'm Steven.
Stephen. Okay, so how much commenting do you think we should have in our code?
I think comments should be used to explain like what chunk of code does what, so maybe not too much. Does it
So
confuse?
not too much, not too little, just right. So just like the 3 bears, it's possible to have too many comments, too few comments, and what you're aiming for are comments that explain the bits of code that would be difficult for someone to understand just by reading the code itself. So for example, if you have a function that is called sum, and it calculates the number of items in a list, adds them together, and then divides one by the other, that probably doesn't need a very large comment on its own. You don't need to explain step by step what you're doing because it's a function that people used to coding will have seen many times before. And so adding additional comments will make your code longer, but not at the benefit of actually explaining the code to someone. You have to remember the audience for people reading your code is other programmers. They're not teachers or professors or anything like that. There's a very clear function for the comments. It's your future self or someone very much like you trying to come back to the code and understand why it's structured the way it does, and if you want to make a change, what kinds of things you have to change. Now, there are a lot of different ways that you might write comments, but one of the ways that is actually most useful is called the docstring. And these are common in a number of different languages, including Java, that you'll see hopefully if you take more programming subjects with us. And the idea of a docstring, and let's say to expand it out, it's a documentation string. The idea behind it is that it should actually not just provide line by line comments, but that we should be able to explain to a user, for example, how to use the different functions in our code. What are their inputs, what are their outputs, and what does the function do? So this is an example of a docstring. We've indicated it by creating a comment, not using the pound symbol, but by just creating a string with no variable name immediately after the function's name. And what we've done here is we've provided a brief explanation of what this is actually going to do. So let's try this out on my computer. And here we have a basic docstring. Let me hide that. There we go. Okay, calculate the total cost after applying a discount. Now, what I've left out here is the actual details of the function, because right now we're just concerned about seeing how to use the docstrings. So now in my IDE, and IDE stands for Integrated Development Environment. It's a program that you can use to type your text to write other programs. I'm going to type in calculate total cost. And then when I open my parentheses, because this is a program that's expecting us to be writing code, it knows intelligently to read the docstring and actually bring that up as a suggestion or as an explanation for the programmer. So one thing that you might want to do as you go throughout semester is to move beyond using Grok to using one of these programs that's actually more specialized to helping you write code, and then it can help provide suggestions. So now we see that our docstring appears, calculate total cost, and it brings up, no matter where else it was in my program, it'll give me the details of it. So that message that I had over there, calculate the total cost after applying a discount, has showed up again. So let's try this with a function that we don't know as much about. So for example, .capitalize, for example. Let's pretend we didn't know as much about it. And now if I open my parenthesis again, it'll say, return a capitalized version of the string. More specifically, make the first character have uppercase and the rest lowercase. And so you can learn a lot about what functions in Python do just by opening up an IDE, one of these programs for writing code, and seeing what happens when you start typing things. But there might be lots and lots of different ways of writing these docstrings. And so it probably makes sense, just like we have conventions in Python, to have some conventions around what the docstrings actually look like. And that can make our IDEs even more powerful and give us even more information about how we're supposed to use functions. Because most functions at the end of the day take arguments, And we're going to need to know about what kinds of arguments they expect, what type are they, what format should they be in, and all those sorts of things. So one very common type of docstring, and this is used in lots of different programming languages, and sometimes in Python, there are lots of different conventions that people might use in Python, is this one called restructured text, or REST. And it looks something like this. So this is an example of a completed docstring using the REST format. So I'm going to change our lighting for a second just to make that a little clearer. And you can see over here that I've explicitly detailed the different parameters that my function is going to take. So I have a parameter, which is the base price, and then I provide a description to the user of what it's meant to be. And then underneath that, I'm going to indicate the type of that parameter. Then I'm going to put another parameter that's the next one, quantity. And then underneath that, I'll put its type. And then at the bottom, you can see a description in return of what semantically, what meaningfully it's going to return. And what meaningfully it's going to return is the price after discount. And then I also have R type, which is the type of the return value. Yes, and your name was, give me a second. Tom? Yes. Got it eventually.
What about specifying the data types of the variables using colons?
So we'll talk about that. You're a little too far ahead. But Tom has some very interesting and clever ideas for how we can help Python know what types we're using. And we will get to that. Okay, so now let's try our new docstring. So we have our fancier docstring over here, and I'm going to do the same thing as before, start typing out calculate total cost and open my paren. And now I can see that the full docstring has appeared, and now I can quite easily see the different contents of the different kinds of inputs that I need to pass to the function in order to ensure that it works. Now, Tom beat me to the punch here, but one thing that Python unfortunately doesn't do for us automatically is make for certain that we're actually putting the right type into the right function. So I said in my, oh, there we go, I didn't bring it up. And unfortunately, this means that Python isn't type safe. You can pass functions the wrong type, and Python will still run. It might hit an error, but it's not going to force you not to put the wrong type into the right function. When you launch the Python command, it'll still run, it just might run into an error eventually. So one thing that Python has done in recent years that has not been part of Comp 101 before, so you're the first class to hear about this, is type hinting. And that's where you can let your IDE, or you can let Python know what types to expect for things, and then you can actually start getting it to enforce this. Now, unfortunately, there is a lot of old Python code up there that doesn't do this, which makes it a little more difficult, because when you are writing code, very frequently you'll be interacting with other people's Python code that may not have been set up. And so very frequently we'll find that we can't make Python truly type safe in the way that we'd want, but by starting to introduce these hints into our Python programs, we can at least do better than we did before. So here's an example again of our same program that we had before, only now I've added in type hints. And so you can see after each of the variables in this program, I've actually added a colon and then told the computer what type to expect. So base price is a float, quantity is an int, discount rate is a float, and I haven't added the docstring here, not because it's a good idea to remove the docstring, but just because having the docstring would have made this pretty long. However, adding the type hints may allow us to reduce some of the docstring because now the types are documented in the code itself. So let me open up my Python program now with the type hints in it. So let's put that on one line. I know I'm exceeding my 80 character rule for a second, but just to make it a little more readable for the minute, you can see that now calculate total cost has these in there. And so let's comment out that line for a minute and type calculate total cost. And now when I do my open paren, you can see that the IDE is actually showing me what types I should be putting in there. So it says I should be putting in a float, an int, and then a float. And at the very end, you'll see this little arrow thing, and this comes up when using a function, and this indicates the return type of the function. So the function is going to output a float. And so up here, after the close parenthesis for my function, I've added an arrow and then the type that the function is going to return. And this also helps you compose functions correctly because you know what type the output of the function will be. And so if you pass that into a second function, you can be sure that the second function is also receiving input of the correct type. So now, if I uncomment my line before, you may have noticed that my IDE, which in this case is Visual Studio Code, has put a red squiggly line under the number 7. Why? Who's got the microphone now? You want to pass it on? We're playing hot potato with the microphone. Okay, what was your name?
Ella.
Ella? Okay, why do I have a red squiggly line? Why is my code unhappy?
Because you've got a string type in there.
Yeah, so that number 7 is not actually an integer 7. It's a string that contains the ASCII character for 7. So that's obviously an error, but now my program knows that it's an error because I've added type hinting. So if I remove the type hint, let's say I remove that hint, suddenly the red squiggly line goes away. That doesn't mean that my program's correct now. It just means that I haven't given the IDE enough information to deduce that that's a problem at this point. So I'm going to put it back in, and I'm actually going to run the code and see what happens. So this was week 5. So Python, and I called this typehints.py. And it's actually still run, but then it gets to line 2 over here and still runs into the same kind of error that would have had if I didn't have the type hint. So let me remove the type hint and see what happens. And I still get the same error. Ella, do you have a guess about why this might be? This is a tricky question, so just a guess.
You still haven't fixed the original part.
Yeah, so I still didn't fix the original error, and Python itself is not going to enforce the type hints. We can use other programs like our IDE to tell us about the problems that the type hints are indicating, but the language itself and the Python program that runs our code isn't going to do that on its own. So this is where we're going to start introducing tools to actually help us make our Python code better. And the first one that I want to talk about is a tool called rough. Now, if you Google online Python formatting tools, there are millions of these. And in fact, in prior versions of this course, we have many times used a tool called AutoPep8, which does mostly what you'd expect it to. You give it a code file, and it automatically puts it in PEP8 format, even if you hadn't. However, I think the tool has a few things lacking, and a tool called Rough does a better job. There's also one called Black that's very popular. My favorite is currently Rough. I looked it up this morning and played around with it and got really excited, so that's what we're using. And so let's do a demo with Rough. And for those of you who are interested in using the tool, this isn't going to be compulsory. It's not supported by Grok automatically, but I'm happy to discuss further how to get it set up and working. You can ask your tutor as well, or we can post on Ed actually how to get these tools set up and running. So this is a bit of extension. Okay, so now I'm going to run rough format on messy.py. And you can see that messy.py is pretty messy. It doesn't have the spacing done right. The indentation is a little funny. Okay. Failed to parse messy.py, unexpected indentation. Okay. Ella, do you know what's happening?
It's like flagging what the problems in the readability of your code are.
So this doesn't look like a readability problem. What is this problem?
Or like how it actually runs because the indentation's wrong.
Yeah, so this is what we remember a syntax error, when I actually haven't followed the rules that Python needs to actually make the program work. So what do I need to fix here?
The indentation.
Yeah, so concretely, what do I need to do?
Move the return value to the right.
So I need to indent things correctly. So I'm going to de-indent all of these and then indent them correctly like that. Okay, that looks a little better. Now I'm going to run python messy.py. Okay, so it seems that there are some logic errors. We'll handle those after. But we might now be able to at least run rough to get the formatting to look a little better. So let's run rough format messy.py. Oh, and all of a sudden my code changes. I now have much better spacing. I can now see that I'm raising the radius to the power of 2, and for this, when we do exponentiation, we typically don't include a space, unlike when we do multiplication. And it's all cleaned up now. But unfortunately, rough isn't going to pick up on the fact that name equals 42 doesn't work for my code. So if we look here, def greeting name, hello plus name, there's still a bug in my code, and rough hasn't picked that up. And even if I run the command rough check, which is going to run some checks, all checks passed. So what is this telling us? Ella?
That you can't just use the rough to fix your code. You have to do some of it yourself.
Yeah, so rough isn't going to be the fix to all our problems. But in this case, with this particular error, what's something that we just saw that we could have used that would have helped us spot this error? We just saw this like 3 minutes ago. Yeah, what was your name? Take the microphone so I can actually hear.
Angel.
Angel.
Yeah.
Okay, Angel, what could I do?
I think you could just use the IDE itself, and then it would.
So yes, kind of, I can use the IDE, but more concretely, Tom? What could I use to fix the fact that I'm getting a bug in this bit of code? When I pass 42, it's giving me an error on line 8. Yeah, I could specify the type. I could use a type hint. Oh, there we go. It's not string, it's str in this case. And now the IDE is going to tell me that there is a problem because the types don't match up. And also, if I run rough check now, rough check doesn't do that. We'll need another tool in a minute. There are now other tools that we can use that are going to pick up that error. So it hasn't solved all our problems for us. But this discussion leads to us talking a little bit about bugs. And bugs are the description that we use in computer science for specific forms of errors in our code, mistakes typically. And the terminology has been used all the way back to the 1800s. Here is a letter from Thomas Edison talking about a bug in his machine. It wasn't, in fact, invented in 1947, which is the common apocryphal story. So the apocryphal story is that Admiral Grace Hopper, who is one of the leading women of computer science, discovered the first bug, and that was an actual bug in an MIT computer, and then all bugs were known as bugs after that bug that made the thing actually not work. Unfortunately, that story is not true. Probably Grace Hopper actually did popularize this story, and it did actually happen that a bug was the cause of the failure in this particular program, this moth that was stuck inside the machine. But it's just a nice example of the concept, not actually the origination of the concept. So fun story that is not true, but feel free to retell it anyway. And so we have a number of different classes of bugs. We already talked about right before. Ella caught for us a syntax error. So that's where the rules of how to structure a Python program haven't been obeyed. And so then if you try and run your code, you'll just see Python says syntax error and won't even start running at all. But then there are also runtime errors, which are once the program actually starts running, that's when you see the error. So that's what happened before. When we ran python messy.py, and we got this error that we could see only after the program had actually started executing it. So it had to get all the way to line 8 before it actually realized that there was a problem with the code. So other examples that you might get that are of runtime errors are divide by zero errors. So let's say you have a whole bunch of variables and you eventually set one of the variables to 0 and then divide something else by it. That's going to cause a runtime error. In Python, we're going to use try catch blocks. We're going to use try except blocks to handle these. But the fact that we've handled an error doesn't mean that there isn't an error in our program. There may still be an indication of bugs. So the fact that you've made an error disappear does not necessarily indicate that you've solved the problem. Because aside from just a runtime error, your program may actually have a logic error. So there might be some mistake that you've done actually in the semantics, in the conceptualization of what you intended to do in the code. So now I'm going to give you 3 minutes. Ooh, I accidentally showed the solutions, but I'm going to give you 3 minutes to look over this code and tell me everything that's wrong with it. So write down, if you've got something to jot down on, all the different errors you can spot. Okay, we'll start taking some volunteers. Where are my bugs? Okay, your name again was? Gabriel. One bug.
The first letter of pattern is capitalized, which shouldn't be capitalized.
Over here, so I have not observed case sensitivity with my variables, so that should be pattern. And that one was highlighted in red. Tom, we've already heard from you today, so I'm going to take from someone else. Yeah, what was your name? Ryan. One bug. First line, missing a colon. Oh, I must have gotten up on the wrong side of bed this morning. Alishka, have we already spoken to you today? Okay, good. Okay, I'm just printing the string n, and I should have been printing the value n. So I've caught a few of these now. Some more bugs? Dritty, we've already heard from you, sorry. Now the bugs are getting a little trickier. All the way over there. What was your name? Lara. So return is probably what we're going to want to do, and we know that because not because we're using a for loop, but we've got our docstring over here, which tells us what the function's meant to do. And it tells us that it returns the number of time pattern occurs in the text, but we weren't actually doing that before. Okay, so we have almost gotten there. We have 2 more bugs. 2 more bugs that I know about. There might be more.
Okay, I think n should be indented with the 4.
So what's the problem with n?
I think it should be if it's, oh wait, actually that's correct because
that's fine.
Yeah, it's fine. Because if you found the pattern, then you add n, which is what you want, I think.
Okay.
Yeah.
Other bugs. There are 2 more bugs left. Okay, it wasn't Kevin, was it? No, what was your name? Peter.
Not quite sure, but like, should it be -1 for the minus text minus?
Ah, Peter picked up on an off by 1 error. So this needed a +1. Was that what you were suggesting? Almost.
Yeah.
We gave you a freebie. Okay, so we had an off by 1 error, so there was a logical error because remember that the range is exclusive of the number of its second argument. So you need to increment that by 1 if you actually want to include that additional value. And then we have 1 more bug. Yep. N is not defined. We didn't define n anywhere. So what should we do over here?
N equals 0.
I heard someone say that.
Initialize n.
Okay, Angel says initialize n, so we should set n equal to 0. And there we have it. I think, so we're going to end a few minutes early, but one problem that we have with some bugs is that not every bug just means the program doesn't work. Some bugs are actually dangerous. And when a bug is dangerous because someone might misuse your program, we're going to call it exploitable. And we're going to call the bit of code that leverages the fact that there's a bug to do something evil an exploit. So this is a very, very common exploit that you'll see people, this is a very common vulnerability that you'll see people exploit. And here we are taking something that the user inputs, so enter which file name to delete, and then we're running it as a command on the operating system. So this os.system command, it's a function in Python that allows us to run a command just like you were typing it in the terminal. And the rm command deletes whatever its argument is. And so we're letting the user type in whatever they want and then delete that. Now, ordinarily, that might be an okay thing to do if you would confine the user to only entering things that the user was allowed to delete. However, there is a bug here in that the person who wrote the code has neglected to check just what the user has entered and being very careful to make sure that the user is only allowed to enter things in the expected format. Turns out in the programming language that the terminal understands, when I type in commands into the terminal, you can always put a semicolon in, just like in Python, and then give it a second command. So now imagine the user enters a file name that they're allowed to, followed by a semicolon, followed by another command. You've just given the user the ability to enter whatever command they like, and your program is going to run it. So that's a vulnerability. So one way that we might try and avoid bugs is by doing something called static analysis. So these are like the tools that our IDE uses to spot bugs and flag them before they get bad. This is also known as linting. So this is not even running the program. This is running tools on our program to help identify bugs. One program that you might want to use to do this is something called Pythonic. And so let's open this up very quickly before we finish off. And now I'm going to run Pythonic on, actually I will run it on our, which one was it? Sorry, I'm figuring out which one we want to do this on messy.py. So Pythonic messy.py. And then hopefully it'll run for us. It's thinking. So sometimes the static analysis tools take a little while to spin up, and this is because it's the first time I've used it on the computer. But you can see here, it's telling us on line 16, argument of type literal, number 42, is incompatible with string. So it's actually used the type hints to spot our bugs before the program is actually run. And so these kinds of tools are going to prove very, very useful for us to identify bugs before they happen. And so if you are having trouble on Grok, but you're comfortable enough getting one of these tools set up, this could actually be a good way of spotting errors in your project code or in your Grok code before you spend hours and hours and hours trying to figure out what's wrong. So I'm going to close with a short discussion of software testing. And so one other way that you might use to identify bugs in your program is you might write small bits of code that actually test your program. So let's say that you know that a length is always going to be bigger than, that an area is always going to be bigger than 0. So you can write a function which tries a number of inputs and then tests to see, is the result of the area function always larger than 0? Now, you could do that with expected inputs, so just write your own tests and tell it, here are the inputs that I've already worked out in my head or on paper what I expect the outputs to be, and I'm going to check the software does that. Or you could do it using a technique called fuzzing, where you try a whole lot of different things randomly generated, and you try and see which of those make the program break. So this is where we're going to end it, our short discussion of software testing and looking at one example of a test, if I have it here. Here we go. Test messy. So now I have roughly the same code as before. I'm going to delete this bit in the middle, and we're just going to test the area function. So I am going to try and calculate the area of a circle of radius 3, and I've gone ahead on my calculator and calculated what it should be. But because we're using a floating point type and I'm not going to put in all the digits of pi, I'm just going to make sure that the difference in what I calculate using my program and what I calculated using my calculator ahead of time is small. So if I do over here 3 by 3.1415926 by 3, there we go, 28.274, whatever it is. So that's just trying to get us within a reasonable range. So let me run my program, Python testmessy.py. Test failed, incorrect area calculation. And so I've used another Python command here, assert, which tests if what is on the other side is true or not. If the thing on the other side is not true, it raises an error. Now, incorrect area calculation. So this tells me there's a problem, but it hasn't pointed out what the problem is. But if I look higher up in my code, what's my bug? Anyone? What's my bug? You've all been through high school? Yes. Pi should be 3.14159. There we go. I was checking that it was a little too precise and I didn't put enough digits of pi in to actually make it good enough. But there we can see that a simple test caught the bug, and then with a bit more scrutiny of our code, we actually picked it up. So with that, we're actually going to end today and let you off early, and I will see you all soon, probably next week. Have a wonderful rest of week and enjoy CAT on Friday.